Ladies and gentlemen, my name is Natalia Brycht, and I represent the Faculty of Civil Engineering of the Częstochowa University of Technology. I'm very pleased to participate in the Ecology Resource Energy Conference. Today, I would like to present a paper on selected aspects of the gravity ventilation work in single-family houses after thermorenovation, prepared by Professor Małgorzata Ulewicz, Dr. Zbigniew Respondek, and by me. Professor Ulewicz sends you her regards and apologizes for being unable to attend today's conference in person due to her professional duties. In the 1990s, ethics became popular in Poland. This technology is based on insulating the walls of buildings from the outside with thermal insulation boards, mainly made of polystyrene. This technology allowed for easy and quick thermal renovation of existing buildings. Single-frame windows with insulating glass units were also commonly replaced because the old-style windows were leaky and generated large heat losses. This made older buildings more airtight. Most of these buildings had classical gravity ventilation. It quickly turned out that excessive sealing of building envelopes generates problems related to insufficient air volume needed for supplying ventilation. Based on literature reports and own research, the most common adverse phenomena related to gravity ventilation in older single-family houses were analyzed. The previously described thermal insulation measures disrupted the natural ventilation process due to an insufficient amount of fresh air supplied, leading to the formation of the so-called sick building syndrome. This unfavorable phenomenon affects both the health and well-being of residents, as well as the structure of the building. The water vapor accumulating inside causes growth of fungi and mold, causing the destruction of structural and finishing elements of the building. In the figure, we can see biological corrosion of the roof window frame and destroyed gypsum finish as a result of running of condensate. One of the key effects of disturbing the ventilation air flow is the phenomenon of reverse drought. One or more ducts in the building being drawing air to supply other ducts. This can result in a perceptible rush of cold air. A frequent action in such cases is the clogging of the inlets of the ventilation ducts. But then the used air cannot be replaced and the microclimate deteriorates further. In older buildings, brick ventilation ducts are grouped into chimney shafts, together with smoke or flue glass ducts. A very dangerous phenomenon in this case is the possibility of blowing fumes into the ventilation ducts. The figure shows a diagram of one of the floors of a typical building from the 1970s. Two chimney shafts consisting of classic 14 by 14 centimeters ventilation ducts and a 14 by 27 centimeters smoke duct are connected with ventilation inlets from the rooms P1, P2, and P3. And from the kitchen, here a classic inlet K and a mechanical ventilation inlet associated with the hood above the gas cooker I used, OK. The hood is equipped with a filter which essentially blocks the gravity flow of air. The bathroom was excluded from the measurements as it has independent ventilation. During the test, the bathroom door was closed and the air vent was taped over. The door to staircase was also closed, while the doors connecting the rooms and the kitchen with the hall were left open. The table shows examples of measurements of various operating conditions: mechanical ventilation of the hood on or off, kitchen window open or closed. It has been shown that the activation of forced ventilation of the hood results in the formation of reverse drought in all gravity ducts under the conditions of open doors between rooms. On the other hand, tightening the window restores proper ventilation operation, although temporary head losses are unavoidable here. The reasons for poor ventilation may also be prosaic. The photos show an example of one of the actual rooms. During the last painting of the walls, about 5 years earlier, the ventilation grids were replaced with new ones with a plastic insect mesh. After dismantling, it turned out that the mesh was almost completely covered with dust. This slide shows another example. During the renovation, the cross-section of the ventilation duct in a bathroom was reduced. This led to continuous dampness and dirt on the walls shortly after painting. The solution to the problem may be window desers, available on the market with a self-regulating mechanism of the supplied air. The amount of supplied air depends on the pressure difference inside and outside the room. It happens up to the pressure difference level at which the air inlet efficiency reaches its maximum value. With further growth, the winds deflect to limit the amount of air supplied. This situation may be caused, for example, by a gust of wind. The user can close the diaphragm, limiting its air flow to a minimum. Chemicals on the outlets of the ventilation ducts may also be useful. Their use allows to stabilize the chimney draughts, but it isn't possible to produce it in windless weather. The effectiveness of various solutions supporting gravity ventilation was already described several years ago. According to the authors, it is best to use hybrid solutions, thanks to which the phenomenon of reverse drought, observed especially in calm weather, has a chance of being completely eliminated. Conclusions. The analysis shows that the most dangerous phenomenon related to the excessive sealing of a building partitions is the possibility of reverse drought in the ventilation ducts, especially if it's combined with the possibility of blowing smoke into the ventilation ducts. The formation of reverse drought is influenced by many factors: temporary weather conditions, mainly wind speed and direction, roof shape, height and location of the chimney, duct system, possible leakage, the influence of mechanical ventilation, etc. Unfortunately, most older buildings have chimneys in which the ventilation ducts are adjacent to the smoke or flue gas ones and windows without regulated air supply. Improving the efficiency of ventilation by installing appropriate devices requires certain financial outlays, which is not always the first need of users, whose awareness of how gravity ventilation works is often very poor. Thank you for your attention.